Hello math students, and welcome to our next video, and actually our last video in Unit 1. We're going to tackle absolute value inequalities part 2, and today is the case of less than. So all of our absolute value inequalities, the original problem will have a less than symbol in it. Okay, so notice what I wrote here. Less than, less than, less than. All of these inequalities, the final solutions are going to end up with the word and. So it's the opposite of great or, it's less than. Okay, so let's look at example 1. It says solve. The absolute value of x is less than 4. Let me highlight over that. And I want you to think about that. You can even pause this video at any time to just sort of think about that. Because the first question that I prompt you with is, well, what kind of numbers could replace x? What numbers have an absolute value that's less than 4? What numbers are less than 4 units away from 0? So maybe we could list some out. For example, I think like 0. 0 right here is less than 4 units away from itself on the number line. How about 1? The number 1, that's only a distance of 1 away. So that's less than 4 away from 0. 2, 3. All these numbers right in here are no more than, they're less than 4 units away from 0. But I could also go in the opposite direction, like -1. -1 is only 1 unit away from 0, so that fits. -2, -3. And how about all the decimals in between? Like all the numbers between 0 and 1, between 1 and 2, between 2 and 3. So we could sit here for a long time just kind of hashing over this, or we could make life simpler and just sort of put this statement into words and then find the values on the number line. So what this is saying in words is that we're looking for numbers that are less than 4 units away from 0. So to model that on the number line, let's take a look. So numbers that are no more than 4, less than 4 away. So we can go out to here, like from 0. We can stretch out to the 4, but we can't go past it. We have to be less than 4 away. And we can stretch out to the -4, but we can't go past it. And the reason that I'm putting the open circles on the 4 and the -4 is because we don't want to include 4. If I actually replace this x with a 4, it's a false statement. Absolute value of 4 is 4. 4 is not less than 4. 4 is equal to 4. So if this had an equal to, then I could fill these dots in and include this in my solution, but I'm going to open those because they're not included. Okay, so let's go to our solution down here and let's write the 2 inequalities that meet this criteria. Okay, so one of the inequalities, let's look at the positive 4. We're talking numbers that are less than that. Okay, so numbers that are less than 4. And because ands go in, I know this is an and, because it's both places at once, and x is less than 4, and let's look at this side. We're looking at numbers going this way, so numbers that are greater than -4. Okay, so this is the solution. Now let's do our little trick. When you see the bars, you may think that it's bizarre, but it's not. Just bring it down and flip. Okay, so see how this part is brought down, x less than 4, and this part, much the same as our last video, it's both of these parts that are getting flipped. Less than turns to greater than, 4 turns to -4. Okay, last part of example 1. We all know that for every and, you can write it fancy. So let's write this inequality as a compound inequality, but let's take the word and out of it and write it in a fancy way. So I'm going to change colors for fancy. So we know that we're going to say x is less than 4. So x is less than 4. But now, to say that x is greater than negative 4, this part right here, is the same to say that negative 4 is less than x. See, I flipped this 180. I just took it and flipped it over. And I'm going to click and drag that up here. So the x is here. And now I just put this part on the left side, like so. And there's your fancy way. So your smaller number on the left, your bigger number on the right, your x in the middle, signs point left, cover it up, there's your x less than 4, cover it up, there's your x greater than negative 4. Perfect. Okay, let's look at example 2. Absolute value of x is less than or equal to 2. So in words, we're looking for numbers that are less than or equal to, so no more than 2 units away from 0. Okay, so what numbers are less than or equal to 2 units away from 0? Well, 0 is, 1 is, 2 is, and everything in between. Same way going to the left here, negative 1 is, that's no more than 2 away. Negative 2. But anything beyond the 2 or the negative 2 here would be too far. So we're looking at these values between less than or equal to 2 away. If I would go out to 3, that's more than 2 away from 0, so that doesn't work. Okay, so let's write these two inequalities. So starting with the 2, we're numbers that are less than or equal to 2, numbers less than or equal to 2, and, because ands go in, let's go to the negative 2, greater than, numbers greater than or equal to negative 2. So, when you see the bars, you may think that it's bizarre, but it's not. Just bring it down and flip. Okay. Now, let's write it fancy. Let's bring this guy down. X is less than or equal to 2. Let's bring this guy down, but to bring him down and attach him with this statement, he has to flip 180. So the negative 2 comes over here, the x comes over there, and this flips. So it's going to look like that. Fancy. X is between negative 2 and 2. Smaller number on the left, larger number on the right, x in the center, and it will, if you put the smaller to the larger, the signs will always point left because of what I just went through here. Okay, flip it over. It says, example 3, solve. The absolute value of 2x minus 3 is less than or equal to 5. So in words, I'm going to say 2x minus 3. So this stuff that's in here is less than or equal to 5 units away from 0. So this stuff, 2x minus 3, where can it float? Well, it can float less than or equal to 5 away. So it's allowed to go up to 5 and including 5, but no further. So we can go out to the 5 and back to the negative 5. And we can float anywhere between the two. This is where 2x minus 3 can float. Because this stuff, whatever number this ends up being, it can be no more than 5 away from 0. So you can stretch to 5, you can stretch to negative 5, but that's it. You go beyond it, you're too far. So let's set up our two inequalities. So I'm going to write that word and here because we know it's and. It goes in. So let's look at the 5. We have to be 2x minus 3 has to be less than or equal to 5. We'll put that on this side. less than or equal to 5. And over here, it has to be greater than or equal to negative 5. Okie dokie, solve them down. This takes a little bit more algebra than the other one, so I'll have to add my 3. That's going to give me 2x is greater than or equal to negative 2. Divide by 2. X is greater than or equal to negative 1. It's the first part of my solution. And if I add 3 here, 2x is less than or equal to 8. Divide by 2 on both sides, and x is less than or equal to 4. So there's my solution, compound inequality. Now, if I want to write that fancy, I'll take this part first. X is less than or equal to 4. And to attach this part on, I'm going to flip that 180. So the negative 1 will come down here, the x to the right, flip the symbol, click and drag that over here, and you've got yourself a fancy inequality. So here it is. We're less than or equal to 4, but we're greater than or equal to negative 1. Small number, larger number, x in the middle, signs point left. And again, this just means that the x values that you can plug right here and have this whole inequality be true have to be between negative 1 and 4 inclusive. Okay, so our last problem, example 4, solve this absolute value inequality. Now remember, we can't do anything, not even words, until the absolute value bars are alone. So I'm actually going to do a little algebra ahead of time here. So Uncle Joe goes over, let's add 3 to both sides, bring down 2 times the absolute value of 4 minus 2z is less than 18. And then I'm going to divide by 2, cancel that out. So now I have the absolute value of 4 minus 2z is less than 9. So now I can go over to my words. So this 4 minus 2z business that's in the bars is less than 9 units away from 0. So it has to be less than 9 away. So here's 0. So we may go out to 9, uninclusive on the 9 because it's not less than or equal to. And we may go out to the negative 9, and we may be anywhere in between. This is where 4 minus 2z can float. So setting up our two inequalities with our and, we know that 4 minus 2z must be less than 9. Put that over here, less than 9. And 4 minus 2z must be greater than negative 9. So when you see the bars, you may think that is bizarre, but it's not. Just bring it down and flip. See how we brought it down here? See how we flipped it here? When I say flip, again, you flip that, now it's greater than. You flip that sign, it's now negative 9. Okay, solving it down. This time here, since the z is second, we'll minus this 4 over. That's going to give me negative 2z is greater than negative 13. I'll divide by negative 2. Here comes that little rule. When you divide both sides of an inequality by a negative, you flip your symbol 180, so it's going to turn to less than positive 6.5. And we'll do the same thing on the other side. We'll minus 4. So we have negative 2z is less than 5. And we divide by negative 2. And so z is, flip it, we divide it by a negative here, so greater than negative 2.5. Okay, so here's my compound inequality. Now if I want to make it fancy, my bigger number of the two is the 6.5, so I'll put that on the right side, 6.5. My negative 2.5 I'll put on the left, it's smaller, z in the middle. And if you look at this guy, z is less than 6.5, but it's bigger than negative 2.5. Since these two are switched around, if I would switch these around, this would flip. So he now points left like he always does. There we have it. So Z, whatever we're going to put right here, has to be between -2.5 and 6.5 in order for this entire statement to be true. Let's just show that. I'd love to show just like one that works and one that doesn't, just to prove this, because we haven't done this here on this sheet. Let's just do it for this one. So if we're picking a number between -2.5 and 6.5, something maybe easy to work with, maybe like the number 1, let's let Z be 1. So let's let Z equal 1, because 1 is between a -2.5 and a +6.5. Let's go up to our inequality statement and let's type it in, but we'll fill a 1 in where this Z is. So watch the screen here. So it would be the 2 on the outside here. Absolute value is math num 1. There they are. Then I have the 4 minus 2 times the Z. I'm putting 1 in. Come out of the bars, -3. Now when I hit enter, if Z works, this answer that I get should be less than 15. And I get 1. So it worked. And it should work because I picked a correct number in my interval. Now let's pick something, I'll put like a star here or like a smiley face, like that one worked. Now let Z be something not in this area. Let's let it be maybe 10. 10 is not within these boundaries. So let's let Z equal 10. Let's go back up here to math num, absolute value, 4 minus 2 times 10, kick out, -3. Now when I hit enter, this answer should not be less than 15. And see, I got 29. So this is a frowny face, and it should be. The only answers that are going to work for Z are going to be within these bounds. Okay, so hopefully this made sense, and we'll see you in Unit 2 because this is our last video for Unit 1.